It's 5:30. I figure we'll just get going. So the goal of this conversation is going to be really my experience of the Salt over the last year and how do we bring our Juniper environment into the Salt world. So a little bit about me. I worked for Liberty Mutual. I've been there about 13 years, till about 20 years doing network security and a lot of Unix administration stuff. CLI guy. Gotta love CLI. And, you know, my philosophy has always been if I can script to automate it, I go for it. So, you know, I call this, you know, dawn of stealthy and the dark ages. So 2011, we started dealing with Juniper SX firewalls. And we started building a lot of automation to do a lot of scripting automation to help us manage the systems. A lot of the back end scripts that allow us to figure out where things are in the network, scripts that would back up various data points throughout the firewall. So at one point in our time, actually, as of last year in our time, we had about 150 configuration points that were monitoring on the firewall. So these configuration points were things that we called hardening points for PCI. They weren't so much rules, but they're more along the line of standard users, passwords, who can log into the firewalls from where. So there's about 150 different configuration points across about 100 Junos firewalls. So those firewalls were hardware firewalls. If we look at from a virtual standpoint, it was like at one point up to 500 plus. So if we look at if you're not familiar with Juniper, you can have virtual subsystems running on it, but it's all under one hardware layer. So if you look at from the hardware layer, it's about 100 firewalls about a year ago. So when we started this journey within SaltStack, we wanted to see, you know, what benefit could it bring to Liberty Mutual and our admins out there. So we spoke to one of the admins out there that was in charge of going through all of our audit findings. And we asked them, how long does it take to really resolve one audit finding average? Some take less, some take longer. He said about 5 minutes. So we did the calculations at that point that if it took 5 minutes per item per device, and we had 500 issues to resolve, it was going to take about 40 man hours to resolve all the issues, assuming they had nothing else to do that week. So one of the things we wanted to see is what could we do to, one, automate that so these drifts don't happen anymore, but also cut down on that time. So that's really kind of how we started this whole journey back when, you know, we called it our use case number one. You know, how things worked. So let me back up a little bit more. So how those scripts work kind of in the back then was we did a series of shell scripts that were loaded on each Juniper firewall. Those shell scripts relied on a set of SSH keys being installed on each firewall and cron tabs being updated on each firewall. So every time we brought up a new firewall, we had a series of 8-ish to 10-ish steps that we had to do on the firewall to make sure it reported back to our environment. We ran into issues where, for you name the reason, not all the steps happened. So we had gaps in some of our automation. So even though we had monitoring set up, we had gaps out there. So another goal of this was how do we get rid of all those manual steps it takes to bring a firewall up on the network and keep it maintained. So this is an example right here of some of the, hopefully you can read it. You know, this is an example right here from the cron tab that we had on each Juniper firewall. So we had 11-ish scripts running out there at various different times throughout the day to grab various different data points. This one right here, number 4, I highlighted because we use this as a nightly pull to pull down a copy of the most recent config, or the running config on all our firewalls. And that's kind of how we did our auditing in the back end. Now we had Juniper Space that did another set of auditing for us. But we use this really as a text copy of the Juniper config that we could download and then we could rip apart and pull out various different things out of it. But out of all these other scripts, you can kind of see what we had running. You know, this one was a catch-all in case we couldn't upload data from the night before or hour before. This one, so this right here, we're grabbing some other raw config files. You know, we can see we're pulling down cron tabs. Coming down here, we're pulling CPU status, cluster status, just various different things through different times of the day. Some once a day, some several times a day, some several times an hour, just depending on how often we wanted to capture those data points. Those data points were either sent out to a Unix system via an SCP feed, or they were sent up via syslog feed up to Splunk, and we use those data points there to do some alerting. You know, one of the issues we found with the syslog feed was HTTP based. So it wasn't guaranteed delivery. And that causes some problems in itself. So use case number one, salt. So bring salt in. So by the time we got salt in, those 150 checks went up to about 159 salt checks that we wanted to do. So on use case number one, we brought salt in, I think last April, to sit down with us for a week or two to really drive out how we're going to do these checks. So we have about 159 checks that we're now doing across the Juniper firewalls. You know, we went from 100 firewalls down to 50 firewalls. And the really why it went down to 50 was because within Juniper, it's one big virtual chassis. So instead of pulling configs down from each box of a cluster, one on node 1 and node 0, we're really pulling from just one node. So now we're pulling down less data across the network. We're saving bandwidth that way. We're saving resources on the files, not really touching one of the firewalls. So that's how we got, the number in half. So with Salt, we could programmatically say which one's up, which one's active, which one do we prefer to pull from, because we can get the same exact data. No matter which one you go to, you get the same data. Important to note how we're doing this. We're doing this with Salt proxy minions. So even though we're pulling from 50 firewalls, we still have to have, roughly 100 proxy minions out there, because we have to have connectivity to both, as of right now, to figure out who's up, who's primary, which one do we really want to talk to. So it's 50 firewalls we're talking to, but it's 100 proxy minions in the back end. And someone talked about the proxy minions earlier today in another conversation, but that's how we're doing those. So what we're able to get it down to was, on average, when we found a configuration setting out of sync, based off my timing, within about 2 minutes, Salt was able to see there was an issue, determine how to fix the issue with the help of a backend shell script, and then push that remediation back up to the Juniper firewalls. So with Salt, we were able to get all these resolved within 60 minutes. Disclosure, we haven't turned them on all yet, all the checks on yet. There's still some going through testing, so we don't have them all fixed yet, but the checks are built there. So, but the big takeaway from here would be, whether I'm fixing one of the audit issues, all 159 audit issues, it's 2 minutes. It's not 2 minutes per check, it's 2 minutes, because I'll fix them all at once. So there's really huge time savings there, and it's automated. With Salt, we're going to, every time, instead of doing a check once a day, we're going to do a check every time someone changes a config on the firewall. If they change it 10 times a day, we're going to do a check 10 times that day. And we'll go through the cycle, which I'll show you in a second, each time to see, did one of the key knobs change? And if so, let's change it back. So this right here is my flow of the automation. So you can see here, the way it starts is the Juniper firewall sends via syslog feed a message up to the Salt master. It's basically a commit complete. It's a default message that comes out of Juniper. You can set your reactor to react off any message you want. We pick commit complete. So you have to send a syslog message up to the Salt master. The Salt master receives that message, and then based off that message, it determines what it wants to do. So within that Salt reactor, it keys off a state file. So it's hard to read up there, but it's up there. The Salt reactor kicks off a state file. That state file is programmed to go out, and for those that like code, I'm going to show you code afterwards. The state file is programmed to go out, pull down a copy of the Juniper config, do a bunch of validation against it, do some sanitation against it to remove passwords, but then do a audit check against it. Did one of those 150 knobs change from what it should be at? So down here, the master sends a message down to the minion. Minion, please go grab the firewall config. The config gets sent back to the minion. The audit, all those validations things kick off, where I check to see, did I get a good config file? I sanitize passwords. I upload a copy of that config to GitHub, which I'll get to later. And then we kick off a script that says, is that config within compliance? If it's within compliance, it ends there. The job's done. We're good to go. If it's not within compliance, that script that determines if something's in compliance will actually generate a set of delete and set commands for the Juniper to fix what all those knobs are. So I watch the exit code on that script. 0 were good, anything other than 0 were bad. So if there's a non-zero exit code, I actually send another event to the event chain to the master saying, there's a problem. The master takes that event, sends a message back down the menu and says, okay, let's go fix that problem. So it takes that config, pushes up to the firewall, and it uses the pre-compiled or I guess you call them state, the functions that are out there, to load a config on the firewall, do a diff so I can actually see and track what is changing, and then commit that change to the firewall. Once that change is committed to the firewall, the whole thing starts all over. We get another commit complete, we send a message to the master. The master tells the minion, pull down another config. We pull it down, we send it to GitHub. We do all the validation checks on it. And at that point, things should be clean, so we stop. There should be an exit code 0. If it's not clean, it starts all over again. And yes, you can get into a loop. I had a loop, because I had an error down there where one day I had a loop of like 50 commits that happened in a couple minutes because, well, I had a loop. But that's kind of the orchestration chain that we've had set up. It took us from, I wrote the first version of all of that back in November, December, when I first started using Salt. When we had Salt come in to help us with the training, I brought them what I had created and we rewrote all of it. It was a great starting point to help me realize the logical steps I wanted, but I wasn't using nearly as much Salt native things as I could. So really in April, we started rewriting all of it, and I probably had it all done by June. We had it all done where I had to still write some more audit files, but all that orchestration was done and up and working. So, yeah. Yeah, please do. So no, what we're doing is we download our file. So we had something on our project, on our books for a while to start treating firewall code as firewall configs as code. So what we do is we upload the firewall config to a Git repository. It's actually Bitbucket in our environment. Yeah, so it's actually internal. It's Bitbucket in our environment where I call it GitHub all the time, but where we keep firewall configs up there. And that's going to allow us down the line to start treating firewall configs as code, where if we want someone to make a change, we could possibly start using something like Bamboo or one of those other pipeline mechanisms that we can pull in the config, change it, and then push it out. But it's really just the start. And one of the biggest selling points for it right now is our audit team. So before we're downloading the configs every night, we have them in a text file. I can go back a full year for every firewall we have out there. But to actually find out what changed was possible. There's a manual process. There's only someone that knew where they were, pull them out, compare it. It could be done, depending on what I was looking for, anywhere from 2 minutes to 30 minutes, if I'm lucky. With this, I use all the benefit of the Bitbucket just to go in there, and I think I have an example later where it just shows you can see what changed from here to there. Our auditors love it because now they have quick access right into what changed. Our PCI team that has to monitor all our PCI environment to see what's changed, they now have access into this portal where they can just go and see what changed, when did it change. So this right here is just really a snippet of, that's the syslog message that comes in to the master. And this is a copy of my reactor. So the reactor kicks off. It watches for really Juniper syslog, any firewall sending that command line. If it sees that, it kicks off that state file when the reactor. So, and then this is the second reactor I had set up. So if I talked about earlier, I go back this one. Once it finds an issue, it says, okay, go fix it. So that's what the second reactor is when there's an issue, I issue a Junos load command. So those are my 2 reactors I've set up. So down here is, I like code, so I figured I'd show a bunch of code, see what we did, just go through the logic of it. So right here, I'm just set up all my variables. So we come in here, and right here, what I'm doing down here is really just saying I'm always defaulting to node 0. That's how I only have to check one node at a time. I go with the logic of node 0 should always be online, or that's when I want to default to. So I do checks. Is node 0 online? Is it up and active? If it is, great, I talk to node 0. If it's not, I talk to node 1, which that's just our standard naming convention. It follows along with Juniper node 1 and node 0. And to find out if it's online, I run an external shell script. And I think I do a test ping to see if that minion is up. So once I find out which one I'm going to talk to, I start going down here. And this right here is a stanza where I go out to get the firewall config. So this right here reaches out to the firewall and just does the Juniper command show config pipe display. And I pull it down from the minion. I do the display because it's easier to parse within Juniper. With Juniper, it comes out with a default, I don't call it some type of tab stanza. But if you do display, it gives you a set line extremely easily to parse. So this right here, that right here, this is, this is the workaround. So this was what I had to find out if they're online. Yeah, that's the test ping. So this is this code I had right here to find out if node 1 is online. So I'm just simply doing a test ping. Is it up? Great. If it's not. Now, one of the things I did find out recently is test ping may come up saying everything is up, but it's really not up. Because that's just testing communication with the master to the minion, not the minion to the firewall. So I'm going to rewrite that to do some sort of show command off the file, like show version, so I can really test that whole chain going up. But that's what it sits at today. So down here, after I pull down the firewall config, I start down here, and I start doing config checks on it. So this is a key line that's important in our environment for some dynamic groups that we have set up. So I check out here, does that line exist? I just alert off it. That's all I'm really doing off of this one is I'm creating alerts so we can proactively know, is that there? If it's not there, libmute.com is probably gonna be down. We're gonna have a bad night. So that's what that is there. This right here is another state file I created that I call it sanitize. All it really does is takes the all encrypted passwords out of the firewall config. I don't want to upload that to GitHub. So we take out all the encrypted hash values out of it, and really that's it. So then down here, the next thing I do is I move to GitHub. So before I even check to see if the code is, or the 150 knobs are right, I upload to GitHub so we have that snapshot in time of what it is. This right here wasn't that bad to come up with. The hardest part we hit with this was it was an SSH default upload, and I think it was a guy named Dave from SaltStack that was on site. We ended up having to change one of the backend GitHub PI files, I think it was called, because it was going to the wrong port. So we had to hard code the port because it defaulted to a port that wasn't working. So if you do this, it's not working, check that backend file. So down here, here's an example of Bitbucket. So you get up there, I just made a simple change. I changed just the description of interface, but you can see here, auditors can see this really easy. Red removed, green add. We're done. And we have the whole firewall config up there. So down here, here's where I kick off our audit script. So down here under audit configuration, I wrote a state file that within that state file, it goes out and kicks off the shell script that we use to check those 150 knobs. So we go up there, we run that, and then out of that, I don't know if I copied that code, I forget, but out of that is where we send off another event into the event stream bus. If there's an issue, go do something. If not, so after that, we're just going down here and we're just cleaning up after ourselves. We're deleting all the old files, just keep the file system clean. So this is the audit config right here. So within here, all we're really doing is we're pulling our variables for the audit config. So we're pulling our variable GitHub. So when I audit, I'm actually pulling the config out of the GitHub again. I'm doing some logging. So right here, I'm just creating another remote repository, copying files over there. And then right here is I'm copying my shell script to the minion. So when I copy it over there, I made it dynamic, so I replace these values within that shell script so that if I looked on the minion, I actually have a version of that shell script for every firewall. And it helped me with troubleshooting, so I can go out there and see which ones are out there. I can run it on the different firewalls. And then down here was the key to run that audit script. So this right here runs the bash script on the remote file system. And all along the ways, we try to put the require so that the next state couldn't run unless the state before completed successfully. So that is kind of our event chain with the code. Here's some of the nice side effects we have out of it. So this is the monitoring we have set up. So down here earlier, I spoke about that key line in firewall config that we count on. This is a copy of the Splunk alert that we actually go into Slack. So we send logs from Salt to Splunk, and then within Splunk we have triggers built out to send data down to Slack so that we can see visually on our screens, it will pop up, there's an issue, or there's triggers that go out to open remedy tickets. So just like the presenter before they went to Jira, we go to remedy. So we use Splunk for that trigger into remedy. So down here, this is just one of those key configuration points that if it's not configured right, we're gonna have a bad day. This is an example of if there's a audit finding, one of those knobs, we get an event here and it tells me how many findings it fixed right there. So there's one in that one. This up here, I built because I wanted to be able to track, the 3 different, I'm gonna call them states of data coming to Salt. So the blue line shows that there's a commit operation made on the firewall. So I know someone changed something. It has nothing to do with Salt based off purely Juniper log. This second one, it's hard to read, but it's a Salt commit. That tells me that Salt saw a commit, so that syslog message came into the master. These two should always match. If there's a commit on the firewall, we should see it come in. The last one is that the reactor kicked off. I want to be sure that the reactor was kicking off. So I made these 3 in up until about 2 months ago, they all lined up very nicely. When there's a commit on the firewall, within seconds we saw a commit in Salt, and then the reactor kicked off within seconds. We recently went through a Splunk upgrade, and for some reason on the reactor, they're pushing all the logs up by 4 hours. So that's why it kind of looks a little bit different here. So I'm working with our Splunk team now to fix that. But they, Splunk upgrade, they messed up the parsing of one of the logs. But we use this as one of our dashboards just kind of to tell, is the system running? We know someone made a change. Did Salt see it? Did the reactor? I don't look as much anymore. When we first started using Salt, I looked at it a lot because I didn't have the faith in it at that point in time. But that's where that one came from. So this is some of the other monitoring setup. I love Splunk. Call it my favorite toy. We've had it for about 2 years. I love it. So out of all those data points I'm collecting in Splunk, in Salt, I send them up to Splunk and I create all these awesome charts. So this right here is just what we use for overall health of our Juniper firewalls. The top one gives us the overall load on the box is total. This is inbound and outbound load. The one over there is packets per second. This is the session table, and then that's CPU. So whenever we have an issue out there going on, we can go to this board and kind of find out, are our systems healthy? We're working on revamping, it may change, but this is kind of what we use now. But it's an example of how we can generate data out of the Salt, send it up to Splunk, and then really get some value out of it that you don't have to be super tech. You just go in here, go to the right dashboard, and you can see the value. A lot of the upper management will use these boards when they're just looking at different systems, or if we have any big issues going on, we'll jump to these boards. One of the things I found that once I had all this set up within Salt, when we had other random issues going on that I had to run commands across the environment, it was really easy. So something that would take me, so I'll give you an example. We had an issue where we had to compare DNS resolution on the Juniper firewall compared to what we're getting locally on another system. For the amount of time it took me to log into the Juniper firewall, grab the data, compare it to this other system, it looked like the records weren't matching. But it was because DNS was changed so quickly, I couldn't react fast enough manually to grab the data. But by using Salt, I could write a state that pulled out the data I wanted, and then just in another backend script, I could do a quick compare. And it helped show that the problem wasn't necessarily on the Juniper, that the problem was with DNS. The TTL was like 10 seconds. It was just killing everything. So that's just kind of an example of how we've been able to use Salt for just something we didn't plan for, just troubleshooting. Yeah.
So the data are coming from Salt into Splunk. That's feeding it.
Mm-hmm.
Whose package is this Splunk?
This is pure Splunk. So within Splunk, you can tell it to look at certain variables. So when the log message comes in, you tell it to look at certain fields and you say graph it in a certain way.
And so Splunk.
Yep, this is just pure Splunk.
You don't need Tableau or something like that.
No, all I had to do, I just had to know how the log message was formatted, and I could write this all out. And Splunk, I think, has a freeware version out there too, yeah?
Are you using Splunk as a returner from Salt, or how are you getting the data to just syslog going?
Okay, so sorry, the question was, are we using Splunk as a return to Salt? So we originally sent the data to Splunk via HEC connector, and it worked well. Excuse me? A HEC connector, it's our HTTP forwarder, so you connect 443, you send a lot of data there, and it worked well up until the latest Splunk upgrade. Once Splunk upgraded, our HEC connectors were sending resets. And when Salt saw the first reset, the whole environment went down. It killed the Salt master. So after opening a ticket with Salt support, the suggestion that I got was, instead of using a HEC connector, which is a 443 connection into Splunk, was use some sort of Splunk agent where you write to a local file and then Splunk reads out of that. Once I made that change, world of difference. So there's an open ticket with Salt that, the environment really shouldn't die if it gets one reject message. Different story, but that's how we're doing it. So we evolved from UDP to the HEC to the file system read. Yeah.
With log messages from the firewall to the master, you leveraging all those?
So the question was the firewall log messages to the master if I'm using Napalm. Honestly, I don't know. I'm using whatever was in the documentation for Salt. If you do a search on Google for Juniper SaltStack, there's 3 videos out there that I use separate. So if Napalm set up in the back end, maybe I didn't do anything personally for it.
Yeah, it's probably Napalm logs at that point. I was just really curious from the standpoint of, it doesn't seem as though the firewall environment's that big, if there's any scaling concerns.
So we generate 16 to 32 terabytes of logs a day. So one of the things we had to do, and that's all logs across the board. So one of the things we ended up doing on our Juniper firewalls, we don't send all syslogs to Salt. We say very explicitly, we send this one syslog message to Salt. So the syslog volume going to Salt is very small. Yeah.
Is that just the Junos thing?
It's in, well, it was, I don't know if it was written by them, but it was somebody wrote it. It's available. It's a normal Salt agent.
Yeah, I'm just wondering, like, you have an environment with a bunch of different device types.
I don't know how it matters, because all you do is a regular expression. It's a string.
Yeah, so I won't bet as long as you get that string match right, because when the Juniper syslog comes in, excuse me a second, I'll go back to that screen. You can see that it's just matching on.
Yeah, you have to set up the part so it doesn't do it for you. It just sets up.
Yeah. Oh, I lost the screen. But so you set up, when you tell exactly what you want to match on.
There it is.
Yeah, right there.
It's just a string.
So anything you put in there. So this is a star is a wild card, so I imagine you could, but I haven't done any playing beyond it. But I did find that if I sent two, so if I just sent our admin logs, which is, I don't know how big they are, a lot less than 16 terabytes, but I was seeing a lot of data on the message bus with just a few firewalls, and I was afraid of overloading the message bus, so we just parsed it down, and we're just sending a syslog that has that string in it to Salt, so the message bus is relatively quiet. So that's what we're doing there. So, but we're about to expand it to Palo Alto, so I'll let you know. So that's our next step.
Do you have any plans?
Yeah.
Do you have any plans to scale out to other network devices other than your firewalls?
Yes. So in our next, so the question was, do we plan to go to other network devices other than firewalls? So we're bringing SaltStack on site Q1 of next year to help us with more use cases. We're looking at doing Cisco routers, so our network teams get on board. We are currently working on pulling data with CyberArk, pulling back keys, and I think that's what we have right now. Oh, Palo Alto. So those are the two big ones we're hitting next. Palo Alto, Cisco, and we're going to get our Salt Enterprise system up and running. We don't use it yet.
They talk to the IBM guys, they have a lot of risk that, that's 1,000.
So yeah, so there aren't too many slides after this. So this was an example of some of the monitoring we have, but there's tons of dashboards I made. It's just one that I like the best. Like I said, I've used it for just random troubleshooting. I pull stuff from all systems. I love being able to go to the master, just pulling back that data. Some of the roadblocks, HEC connector. One reject crashed the whole system. So we had to switch to the file system read. This is a big one right here. I think we just made headway in the last couple of days. For about 4.5 months, we've had to take out with SaltStack, where some of our firewall configs weren't being downloaded. And it wasn't so much based off size, but it's based off of called complexity within the config. That boils down to the NC client, when it was parsing some of those configs, it must be making some type of array or some type of data set that it was overloading. SaltStack narrowed it down to NC client just in the last week or so. We contacted Juniper, who contributed a lot to that. And the guy in India, his name is Netin, was able to figure out in a couple hours. He uploaded a update just a few days ago to NC client, so hopefully it'll be included in the next release that's coming out. It's something to do with a huge tree, something rather than Python. But that was like 4.5 months of going back and forth. Salt proxy issues. So we've ran into random salt proxy issues where they just stopped working. The conversation we just had a couple hours ago was related to a memory leak issue that they think should be fixed in 19.2.2. So what I've done for now is I actually start it every 24 hours. It saves me from coming in the morning, find out something's not working. Yeah, I restart every 24 hours, but the restart for all the proxies we have is under 10 seconds. Yeah. I run it on, I have a minion, so a minion, so I run it off of that. And there's really salt proxy in that one minion process running on it. I use the real names of each firewall we have out there. We have kind of a standard naming scheme for our firewalls. You know, lack of a better way, I did the name of each device, but then I set up groups within the master file. I set up groups so I can say all Junos, so I don't have to go to each one. So I use a group whenever all the automation I've set up. I do salt dash capital N Junos, and or the direct device names. And then one of the things I did was the top and the pillar files. I got sick of creating those by hand, so I created a shell script that just I can run it and it spits them all out for me. Like I said, I get lazy that way. I automate what I can. So proxy issues, the biggest things we hit was this NC client and has to restart every 24 hours. Besides that, memory hog. So we're running, call it 100 right now. And the system that I'm running on is running 64 gigs of memory. You know, when we're running much fewer proxy mains, we had 8 gigs. We were running good for a while. Then the system started hanging, couldn't log in. We was able to narrow it down to running on memory. We it's went from 8 to 16 gigs. It was better for longer, but it still died. So I called Uncle and I gave myself 64 gigs. At the same time, I'm working on creating a second minion so I can better distribute the load. I'm just working through red tape at work right now, but that's kind of the path I'm going. Right now, we're running all on site in VM Cloud. We're hoping to put these up in AWS or Azure is what we're looking at, somewhere in one of their cloud environments. Right now, they're on site. Do we get that far? I don't know, but that's kind of the thought. Dual vendor support. When we first started working with SaltStack, per the customer standpoint, there was really no SaltStack Juniper collaboration at all. So luckily, we're able to get the two sales teams together with our VAR, Derek right here, from IPC, and they were able to spin up a virtual lab within SaltStack so they can mimic all of our configs in there. So we're really lucky that both sales teams and our VAR all got together in the back end. Even without us, they got a support model working where now I still have to call each vendor open tickets from. We're working on that, but they talk to each other. You know, a great example of that would be the call we just had last week. Ken from SaltStack was up at like 5 o'clock in his time. The guy from India, from Juniper, was up at late his time, and they worked together and troubleshot our issue, that NC client issue, real time. It's been really awesome. Ken and Netin from Juniper have been working within the Git repos on the issue, just to kind of work back and forth, and collaboration has been great. I'm trying to set the same collaboration with Palo Alto right now to get that environment built up. So putting it all together, this is our flow. It's kind of an example of, so I made a change. I deleted the setting that allowed me not to log in via root. I made a commit on the firewall, so I disabled root login. This is the first syslog message at 04:34. It went to the SaltStack and said, hey, something changed. By 04:36, SaltStack, I know that a commit was updated on the firewall because this is another commit message. So within 2 minutes, SaltStack noticed it. It found the config to change, pushed it, it did a Juniper load, Juniper diff, and Juniper commit, and it created that message. And then over here is just kind of an example from the CLI that was my disable, and that was SaltStack re-enabling it and I just hard coded say auto correction by SaltStack. That's kind of, you put it together. So whether it's one knob or 150 knob, it's that quick. There are, like I said, there are some outside of Salt stuff I'm doing within shell script. I've been using Salt less than a year. So as I learn more things, I'm going to turn more things into Salt states. There's a good number there. I'm sure there's things that can be improved. Questions? Any other questions? I love questions. Yes?
You said your whole project took from like January to June.
So
Is that what I said?
about that. So realistically, November of last year, I was sitting at home at night. I built this out at my house. I built the first reactor at my house with like 20 minutes off of, without knowing anything, the documentation I found online. There's 3 videos that Juniper put out that got me to getting a reactor running. Once I had that running for a week or two, I went to my boss at work and said, hey, we should look at this. So then in December, we kind of decided to do it the following year. Then we contacted SaltStack. At that point, we never talked to SaltStack. So January, we probably talked to them the first time. April is when we had the training class. So before we had the training class, it was really me and this other guy at work just learning what we could learn off of Google to get this going. I had a lot of the automation, that first config automation working before April, but it was nowhere near where it is now because I did a lot more scripting than a lot less Salt states. The training class where we had them come in for, it was like 3 days of classes and 7 days of helping us on our initiatives was awesome because they sat down with us. We walked through my scripts I had ahead of time, allowed us to lay out the steps we needed, but Dave from Salt was able to come and say, all right, well, this is how you do it within Salt. We ran into issues and we fixed them, and it wasn't all working by the time he left, but I had enough of a knowledge base from before he came and after he came that from April to June, I was able to get the rest done. A lot of collaboration through email though. So, any other questions? All right, our last slide, my daughter picked out the picture. It originally was a monkey, but she wanted the elephant. So, thank you very much.